Hello, I'm going to talk about a clean air strategy for Ireland. I'm going to divide the lecture into four main sections: what is air pollution, what are its consequences, how air quality is monitored and reported in the EU as well as in Ireland, and then finally what can we do about air quality monitoring here in Ireland in particular. So what is air pollution? It's situations in which a material or some form of energy that's produced naturally or by us occurs in larger quantities than can be tolerated by plants or animals or humans without suffering some kind of harm. And we're all aware of various forms of pollution: car exhausts, emissions from shipping, industrial emissions where coal and coke, other form of dirty fuels are burnt as well. But the natural pollutants like pollen and fungal spores that often give rise to conditions like asthma and like hay fever are also important too. And we mustn't forget very important types of pollution, noise and smell. Very often they are the greatest complaints that bodies like the Environmental Protection Agency get. So why is it important to us? Well, there are two main reasons that it's important. The first is in climate change and areas associated with that, and the other with our health and wellness. Climate change is in the newspapers every day these days. We all know about the plight of the polar bears. But health and wellness and air pollution are also always around us. If it's from the level of asthma and simply coughing, through to lung disease and then death, it's there around us in the newspapers every day. And it affects our population. Our population can be directly harmed, of course, from health issues, but we may find in the future, particularly associated with climate change, the fact that populations will have to migrate. And lots of refugees, environmental refugees now, will be pushed around the world. It's important really that we look after that, because the reasons behind that will always be countries, people having a secure food supply and clean water too. And the bottom line, and there'll be more bottom lines a bit later, is that air pollution costs European economies €1.4 trillion a year in disease and death. And these are figures from the World Health Organization just a few months ago. So, what are the most important? Well, air pollutants. For health and wellness, I would say that they would be ammonia, nitrogen dioxide, which I think is a couple of words that's on everybody's lips these days. Ozone, we know those with stratospheric ozone is something that everybody knew about 20 years ago. Acid rain, that's things like sulfuric acid and nitric acid. And then smoke, soot, which we will always be calling particulate matter in future. And of course, hydrocarbons, general hydrocarbons. They're the health and wellness pollutants. Climate change, which is not going to figure largely in this talk, although climate change does have an effect on health, are things like carbon dioxide, methane gas, and nitrous oxide. So the sources of the air pollutants that we're particularly interested in for health and well-being are fertilizers. Ammonium sulfate is an important fertilizer and will release ammonia. Alongside, on the farm, chickens and their droppings and pig manure. So they release ammonia into the atmosphere and they have a pollutant effect. We all know very well the man-made ones, though, the truly man-made ones, which are like diesel, which without any doubt is bad, and solid fuel burning, things like coal of the various types, but also peat and also wood. What they do is that they produce particles in the end, either directly as primary particles or indirectly, where some of the gaseous releases can go into the atmosphere and then they can react with something else to make secondary particles. If they're small enough, they can get a long way down into our lungs and across our blood-brain barrier sometimes. And what we have then is airborne particulates that are of a larger size, although it's not incredibly large when you compare them to the size of a human hair, what we call PM10, that's 10 microns, which is about a fifth of the size of the thickness of a human hair, can get down obviously into the upper respiratory tract. They often give us rise to the allergic reactions. Smaller ones though, the ones we call PM2.5, which are 2.5 microns each, can get down into the lungs, and they're about a 20th or 30th the size of a human hair. And there are other ones too that are much smaller that we call PM1. But the reason for concern, and what I call the problem with particle pollution, is shown on the graph at the bottom, which indicates the amount of exposure of people to PM2.5 and their life expectancy over a very many number of countries. If you look at the left-hand side, where you've got, say, an exposure of 5 milligrams, a small amount, let's call that, then the life expectancy might be of the order of 80. When you get much more across the dotted line and get to 15 or 20 micrograms, then that life expectancy is probably dropped by about 5 or 6 years to 74 or 75. So clearly we have a health problem. Just recently, 1 or 2 weeks ago, the complexity of how these particles are formed and leading to premature death was shown in a letter from Nature. And there it's something that surprised even atmospheric chemists, the fact that the direct carbonaceous type particle that we often think of being particularly damaging, coming from, say, coal burning or wood burning, all of those things, was perhaps not as important as the secondary particles. So that was when, if you remember, we release a gas, let's say ammonia, into the atmosphere, and they react with other materials, say acids like sulfuric and nitric acids, and we get a whole new set of secondary particles that are added really to the primary particles and cause premature deaths. And what the calculation is for outdoors is 3.3 million premature annual deaths worldwide occur mainly because of agriculture, it turns out, from those ammonia sources. We get them from elsewhere, of course, and I've got there the coal, wood and peat combustion, and as well as very often diesel engines being a very large culprit for releasing particulate pollution, but they also release other things, and we'll talk about that in a minute. Let's talk first though about air pollution particles from solid fuel burning. This week in Ireland there was an announcement by the Minister for the Environment that smoky coal would be banned in a year or 2 or 3 years because of the health and well-being risks associated with it. But let's just have a couple of words about some detail here where we compare coal with other forms of heating, oil, gas, and of course other solid fuels like peat and wood. What you see there is, I'll just pick out the blue ones, the smoky coal, 4.3 kilograms per 1,000 kilograms burnt, compared to gas, which is virtually nothing. So gas is the way to go. But then compared to wood burning, which is double the amount just about of the smoky coal emissions at 9 kilograms per 1,000 kilograms burnt. So solid fuel burning is not good, but other forms of solid fuel burning like peat and wood are not good either, as well as coal. Now, the reason why the ammonia can react with acidic content in the atmosphere is because we have certain things that contain acids or acid precursors. So we have to look at the solid fuel content as well as the other content, let's say from gas, of the acidic part of the material, nitric acid and sulfuric acid. So we've got a table here that shows the relative nitric acid contents of fuels is 1 for wood, 5 for oil and kerosene, and 7 for smoky coal. So clearly in terms of those formation of the secondary PM, there's much more of a problem with smoky coal than there is for wood. Now importantly as well, sulfuric acid, which can go into the atmosphere coming from sulfur content of material, is quite different for all types of coal. Smoky, smokeless, whatever you have, then the relative amount compared to wood is 5 to 50, maybe up to 100 times as much compared to wood. So here, although we know that in primary terms the wood does give out quite a lot of particulate matter, in terms of the secondary particles, which have been established now to be very health damaging, of course, we have a problem with coal of all types compared to wood. I think the answer is, though, if anyone looking at this overall slide, is that really a move to gas is the thing that really should be happening. I'm going to talk a little bit more about the solid fuel burning because we do a project here at UCC. It's called the SAPPHIRE. It's coordinated by Prof John Wenger here, and what we've done over the last year or so is to monitor what happens in small towns like Enniscorthy and Killarney. You may well have heard of the ban on coal burning in Dublin all those years ago and the health benefits that have been since then. But what about the rest of Ireland? And that's why we've been looking at rural sites to see what happens when locals burn fuel of the various types as well. And we work out the various types and the contributions by a technique called source apportionment. I'll just direct you to the CRAC site, a Centre for Research into Atmospheric Chemistry, if you want to know more. But they're not the only problem, particles from solid fuel. Particles can be made in other ways and thrown out from other forms of combustion, really, and diesel engines is one of the largest. But beyond the particles, there's another killer, and it's called nitrogen dioxide, and it can kill directly. This week, there's been nothing else in the news but the Volkswagen emissions scandal, who have been gaming their emissions systems so that when they're tested, they appear not to give out as much nitrogen dioxide as really is thought by the test, and by certainly the people who buy the cars. They exceed what the legislators have said are safe, and so there must be issues in future with criminal charges about whether or not they've committed some form of corporate manslaughter. But this may not happen because it appears that there's been some deal that was done many years ago with Volkswagen, and over in the United States, the legislature there with their Clean Air Act, that they may not face it. But what I suggest is over the coming weeks, you watch this space. So that's the problem. How do we monitor it, and why do we monitor it? And the EU are very active in this area. They've passed legislation, it's called the CAFE Directive, and it has limits of which we must adhere to in the variety of countries on things like the PM 2.5. This will play a very large part in all of the rest of my discussion here. But other things like nitrogen dioxide and sulfur dioxide as well are important. And so we have directives about how much emissions there should be. And what they say in the CAFE directive is that up-to-date information on the concentrations of all regulated pollutants in ambient air, that's outdoors, should be readily available to the public. And countries can do that themselves. What they do is divide themselves into zones. Here in Ireland we have 4, A, B, C, D, more about that later. And we also ought to have a mixture of so-called urban background and traffic orientated sites as well that we monitor the air in. Now, what we do, is that really up to date in Ireland? I've got a big graphic here from a website who give an air quality world index, and what you see is a cluster of real-time air quality monitoring sites throughout Europe, covering it completely, and the different colours stand for how much pollution is there. Green is quite good. Now, that's all very well if you concentrate on this graphic until you look at Ireland, where you see that there appear to be no real-time monitoring information going into this at all. Even if we look a bit closely, Iran has one piece of information going into this real-time monitoring system. There's another air quality system as well that's operative throughout Europe. It's really an A to Z of countries and the air pollution that they have. So on the top left, there's Andorra, Austria, Czech Republic, Belgium, and I've picked out one city from the Czech Republic that gives real-time air quality data that's happening in Brno. We can see that it's all very well. There seemed to be a slight problem yesterday at the roadside, but that's good information, real up-to-date, real-time information for the public to look at there. If we go down the alphabet a bit more, we get to Greece, and then Italy, and of course in between those two ought to be Ireland, and it's not there either. So we don't supply any real-time data to this important website either. So let's wander back towards home a bit, and what we can do is to compare what happens in Northern Ireland and their air pollution, their monitoring and reporting that they have. What we see there is that they have about 21 sites. Their population, as you know, is about 1 to 2 million. Their area is 13,843 kilometers squared. That's from Wikipedia. And they have some coverage, not just in Belfast, but they seem to have other coverage throughout the rest of the country. In Ireland, it looks a lot more sparse. We have our 4 air quality zones. As I've said, we've got Zone A, Dublin, Zone B, Cork. Zone C is these larger cities, over 15,000 population, and Zone D is the rest of rural Ireland. What you can see is, doesn't look as if there's very great coverage. I mean, in Sligo, there doesn't seem to be anything at all. Let's go down and focus a little bit more on what's happening. We're supposed to be 31 or 33 sites, it's sometimes cited as, that are available in Ireland for reporting. What we see, though, when we look a bit closer at the EPA websites, is that there are 31 monitoring sites that are active, but there's very many more that are inactive. A lot of these are in the rural parts, and if we look at the concentration of our sites, then we see that Dublin, as always really, has more than everywhere else. But, and I've talked about this I think at length earlier, is that the CAFE directive says that we should give up-to-date reporting, real time, sometimes it's called near real time, up to date meaning within a couple of hours that the public should be informed. And in fact, there are only 3 of those 31 sites that have real time measuring and reporting of the very important pollutants that are particulate matter, PM 2.5 and PM 10. Those 3 are in Clare, Zone C, Claremorris, which is representative of the whole of rural Ireland, Rathmines in Dublin, and there's nothing in Zone B. Now, our population is 4.6 million and we've got 84,000, so you can make some sort of a comparison, I think, to what's happening in Northern Ireland. Because I'm from University College Cork and I live in Cork, I'm going to concentrate a little bit more on Zone B, because as I said before, there appears to be no real-time data of the particulate matters there. I've put the two sites where there is monitoring that goes on in Cork City. One is called real-time monitoring, but it doesn't do particulates, and the other one does other measurements as well for air pollutants. One point is, though, is that we're supposed to have traffic-orientated sites, and it could be argued with these sites that they are close to the very big roundabout at Kinsale Road. On the other hand, there ought to be some reason for monitoring exactly by the roadsides in the city centre. So moving far more 2 or 3 kilometres into the city centre, maybe St Patrick's should be something that is done in order to give us a real measure of real-time pollutants like nitrogen dioxide, like the particulate matter, because of traffic. So let's just look at those at the real-time site. I mean, I took this data on the 23rd of September and it was reported to the public on the EPA website. The PM, remember I said that that's important, the PM10, just in this case, there's no PM2.5 data that's available from there. But 23rd of September when I looked at it, the very last report was on about August the 16th. That's hardly up-to-date information. The nitrogen dioxide, sulfur dioxide and ozone are a bit more real, although it appeared that the SO2 monitor wasn't operating. So, up to date should mean, in my mind, on the date, not 1 month later. More than that, a very real innovation has happened in the last year or so, where the Air Quality Index for Health has been produced for the EPA website. What happens there is that every 6 hours or so the EPA tweets the amount of pollutants that there are, and here they are: nitrogen dioxide, ozone, sulfur dioxide, and the particulates. And we use automatic air quality monitors to monitor how much pollutant there is. But those every 6 hours that give you information for the Air Quality Health Index are a problem if you don't do real-time monitoring. So the question must arise is, how is Cork Zone B's Air Quality Health Index calculated if there's no real-time particle measurements that are being made? So what's the problem and where can we go from here? First question I think that should be asked is, Ireland's Air Pollution Act from 1987 really fit for purpose? The EPA coordinates and manages our monitoring and assessment program, and it communicates the data, just as I've said, in what's called near real time by them. Now, some of those stations are run directly by the EPA and others from local authorities, because by the Air Pollution Act they have to take whatever measures they consider necessary to prevent or limit air pollution in their area. So it's all local scientific coordination rather than national scientific coordination, and by that I mean that the monitoring should be done by identical sets of reliable equipment all over Ireland. And then this would bring Ireland in line with all other countries of Western Europe that do have their true real-time approaches and do provide the public with up-to-date information, and so they're able to sit and visit and work on those air pollution sites that we saw a bit earlier for giving real-time indices. So really, what can we do? Well, my suggestion would be that we replace the air pollution effect with a Clean Air Act for Ireland. The reason for that is that a Clean Air Act puts front and centre the health of the public at the front. It's a positive message about improving health, and that's its aim. That's its aim rather than the Air Pollution Act, which is simply to measure pollutants to see if they're in line with legal directives. What we need for that, though, is a nationally operated air monitoring program with the identical procedures and equipment that I've said before, and it should be co-operated and operated by the EPA, but they will have to be greatly expanded, and they ought to be as well. Then, actual, up-to-date, real-time information for the public can be provided at many sites throughout the country, not just one site representing the whole of rural Ireland, and then we can add to those world air quality indices and the air quality in Europe webpage. Now, more than that, and from what's happened in the last week with the Volkswagen scandal, is that a new Clean Air Act could be drafted to establish criminal charges by showing that a defendant was aware of red flags about illegal conduct but chose to ignore them, which is known as willful blindness. And the Volkswagen management certainly knew what was happening. And then very often when you don't have an act and a clause like this, the management can claim ignorance, and then they can get away scot-free. I think in a new Clean Air Act, if Ireland had one, there should be some coverage for that happening in the future. What else should there be, though, as part of this, or part of the general thrust? There should be a comprehensive, long-term public education program. It'd be devised by experts like those from the Asthma Society. They know more about what's happening with their disease than anyone else. And they should join up with the Department of the Environment, Department of Education, and also stakeholders like us down at UCC. If you're really going to go for the health front and centre, though, you're going to need something that's given quite a funny name. You need a real-time syndromic surveillance systems to be set up, which are beginning to happen in the United Kingdom. And what there you have, remember, measuring death is quite easy. So that's why there's lots of information about air pollution and death. You just get a death certificate, you go back and work out what the person died of, and then you can work out the air pollution consequences that there have been. But when you're looking at disease, you do need a fully nationally coordinated system between GPs and accident and emergency departments in order to have some sort of coherent national network that then can be put together with EPA results, or this new air monitoring system that we might put into place, and check to see if there's cause and effect. So, for both of these things, the EPA and the HSE roles would need to be substantially increased, and they would be able then to help us develop early warning systems for Ireland's at-risk population, especially those with respiratory disease. I'm just going to give three bottom lines, three figures that I hope you would take from the talk that I've given, is that there are 3.3 million premature annual deaths worldwide, mainly because of PM 2.5 levels, and the scaring fact is this may double by 2050 if we don't do things. The cost, 1.4 trillion euro, the economic cost of the 2010 premature deaths that are caused by air pollution. Perhaps finally, we have, as I've said, just 3 real-time monitoring stations in Ireland for the biggest killers of them all, the PM 2.5 and PM 10, and none of them are here in Cork. I just finish with the words of William Shakespeare, "What a piece of work is man." Thanks for your attention.